Hi everyone. Now, this is a middle of the way presentation, somewhat technical, somewhat not, about various ways to move data between volumes in Cinder volumes in OpenStack. Now, first, a couple of words about me. I'm basically a software developer, have been for quite a long time. I've done quite a lot of open source work, quite a lot of work in various areas of programming, systems, network programming. Of course, like every teenager, I tried my hand at game design too, but didn't quite work out. Now for the past couple of years, I have been working on StorPool, a distributed storage system. And for the past couple of months, I have been working on integrating StorPool with OpenStack and learning a lot of things along the way. So, basically, OpenStack, I don't think I need to introduce it a whole lot, mainly to say that it is not just some set of buzzwords, something about the cloud, something about running virtual machines. It's basically a layered thing that allows you to do everything you want and connect to other applications and other layers that do everything that you need to access for your resources. And a major part of that is accessing various types of data. So OpenStack has several means of storing data, several types of data basically to store. There is the object store for small pieces of data, large pieces of data that you need to update frequently, pieces of data that you store once and never change in the next couple of years. There are images. There is the glance image service that stores operating system images, for instance, or that stores some kind of predefined data sets that you calculate once and then you just use. Then there are the things that I would like to talk about most, the actual Cinder volumes. They are mostly used as file systems for operating systems, be it for the root file system for the operating system or some kind of data that the instance stores there and updates. And of course, the Cinder volumes are not the only way to do file systems and instance stuff in OpenStack. There are other ways to run virtual machine instances in Nova, some with files on the actual hypervisor, some with files on other devices, or other storage types for the Nova image backends. But, well, maybe it is just my viewpoint, but in many cases it is kind of convenient to use Cinder, to use the volume service for what it is meant to be used, to attach volumes of data to various instances and move them between instances and stuff. Okay, so a bit of introduction maybe. In the OpenStack volume service, Cinder, there are several, you have the option of using several various volume backends, that is various ways to store the data. One of the most common examples is the Linux Volume Manager, LVM, but there are also others, of course, various types of shared storage, various types of distributed storage, even, the backends have, the purpose of a volume backend is to provide a way to store data, to create a volume, to remove a volume, write data to a volume from an image, basically create snapshots, create volumes from snapshots, stuff like that. And yeah, as I said, the main idea of a backend is to provide an interface to some actual way of storing data. And there are many such ways. Some of them are local to the hypervisor host, like for instance the Linux volume manager. It can basically only manage volumes that are accessible to this machine. Some of them are shared, that is, the volumes may be accessed from different machines in the cluster, sometimes even at the same time, although at the moment Cinder does not do that very well. For those shared storage systems, there are various options too. You can have a single shared storage node, like some kind of a box or something, or you can have your data on some kind of distributed storage, placed on many machines, many servers, or even many boxes of some type. You can have the data stored on various actual hardware, or hard drives, or solid-state devices. And basically, all of this comes up to different levels of what you can do with the data, how you can access it, and what options the volume backend provides for you. Now, in some situations, it's okay to just build a whole cloud using only a single type of volume backend, but sometimes things are not so simple. Sometimes you may need to have more than one volume backend. If you're not using shared storage, of course, you need a volume backend for each hypervisor. Even if you are using shared storage, you may exploit several volume backends for their strengths. Basically, one for performance, one for the capability to create enormous file systems. Yeah, basically various types. And of course, there is the situation when you already have a cloud and you decide to switch it. You decide to migrate to a different type of volume backend without losing all your customers' data, because that would be a bad thing. And then you necessarily have to run for some time with several volume backends on the same cloud. Now, the main point of this talk is moving data either between very different volume backends of the same type, or moving data between different types of volume backends, different hardware, different software. The reason I thought about giving it was that when I was at the Vancouver Summit, and even before that, in response to a customer question, it turns out that many people know that Cinder has, that OpenStack has a way, a command, a tool called migrate a volume, but not so many people know that it is not always the right tool for the job. It does not always do the full job of migrating a volume, and sometimes it even cannot, because there are other ways to do it. There are even better ways to do it in recent OpenStack releases. Now, things are a bit simpler when the backends between which you want to move data are of the same backend type, say two LVM backends or two something like that. Why would you want to do that? Maybe you want to move a virtual machine instance to a different hypervisor. Maybe you want to use a virtual machine instance, its file system as a base for another virtual machine. Maybe you have built it and you want to use it for 1,000 virtual machines. Basically, the ways that are available, well, in most cases, there is the option of not doing it in OpenStack, of somehow making both volumes available, creating a new volume, and then using the operating system's tools to do that, like tools like DD, which dumps disk data from one device to another, or stuff like rsync that moves data between two hosts. Now, if the backends that you wish to move data between are both, or at least one of them is a shared storage backend, then there is another option. You can just attach a volume to the new host, and this almost completes the moving data operation. There are some somewhat naive solutions, like creating a whole glance image and then creating a volume from the glance image onto the new backend, which is almost certain to work. It's just not always optimal. I will say a couple of words about those in the next slides. There are also a couple of OpenStack ways, a couple of native ways to do that are sometimes quite preferable because, well, they should be the most supported ones, and if they work well. Now, the really interesting situation is when you want to move data between different backends. Now, in those cases, of course, the operating system way is still an option if you can get access to the volumes, and you almost always can do that. If at least one of the backends is a shared storage backend, of course, you can mount the volume, you can attach the volume to a host and somehow transfer the data between them. Or, when I said that migrate is not the best way to do that within OpenStack, I meant the somewhat recent addition, the volume retype functionality in Cinder, which is actually, as of now, pretty much the best way to change the metadata of a volume, including the type of the storage that its data is actually on. Now, a couple of words about each of those methods. Now, first, using the operating system's tools, this could be the most efficient way. If the actual storage mechanisms do not provide another way, this could be the most efficient way to move the data. I mean, the operating systems have a concept of reading data, caching data, writing data. So, if you can do that, it shall work. Yeah, even Cinder does that. I mean, OpenStack uses an operating systems tool to do that, to write data from one volume to another. Of course, it is not always the best way to do it, because you have to do it usually to actually get access to the volumes containing the data, so you can run the operating system tools on them. You usually have to do something to the storage itself to ask it to make the volumes available to you. And sometimes that's not even possible. Sometimes some backends are written in such a way so as to provide the data to OpenStack, but not always to the system administrator, which is kind of weird, but for me to say. And also, one of the major obstacles, one of the major reasons not to do that is that it is often not so easy to integrate that into an automated workflow. So if you have to do that often, or if you have to do that on thousands of volumes, sometimes it is not easy to put it somewhere within an OpenStack workflow of migrating data. Right. Well, if you can get away with using, now this is actually not so often possible, but if you have a shared storage backend and you actually have two volume backends accessing the same underlying shared storage device underneath, then you should be, sometimes there are ways to just tell it to move this volume from this storage backend to the other, attach it to the new host, and that's it. But it is not always an option. And besides, yeah, this if it works, it is absolutely the fastest way. I mean, you just tell the storage backend, move this volume there, and it works. But in most cases, you have to do it in some other way. Now, the glance image way, this is basically guaranteed to work. I mean, there shouldn't be any drivers for Cinder, any block storage drivers that do not support the upload a volume to a glance image functionality, and there are certainly none that do not support the get a glance image and write it to a volume, because that's what you always do to start actually using the storage backend. You start with some operating system image or something like that. The problem with that approach is that it is sometimes a bit slow, because you have to transfer the data twice, once to glance and once from glance, and this is not always streamlined. Transferring the data to and from glance could involve HTTP uploads and stuff like that, which is not the fastest way of transferring data. And also, this takes up space for an additional glance image. So you have one volume containing the original data, you have another volume containing the new data, and you have the same copy of data a third time. But if there are no other ways, this could work too. If the task is to create a copy of the volume on the same volume backend, then sometimes there is a way to ask Cinder to actually clone the volume, and some storage backends make this very easy, basically an instantaneous operation. So for the case where you have prepared a basic OS image and you want to create like many virtual machines with their own volumes to boot from and their own volumes to like run from, then this would be the fastest option. But of course it only works with the same backend, and it only works if you really want to use the data at the same place where it is right now. Now, the migrate functionality of Cinder, this used to be the best approach actually, because Cinder was supposed to handle moving things, creating a new volume, moving the data, attaching, detaching the old volume from whatever, attaching the new one, and then switching the volumes, removing the old one possibly. The thing is, it doesn't really work when you are trying to migrate to a different backend. Actually, it was one of the things that I kept hearing in Vancouver, like almost every day somebody would say, no, you don't migrate between different backends, you retype between different backends, because it's not actually designed to work that way. But if the backends are similar, or sometimes it can work. Or if both backends provide, sometimes migration even works with the help of Brick, that is another connector that helps to attach volumes to different hosts. So basically this should be, how do I put it, the most tested way. I mean, the way that has been in use for a couple of years. So if that works for you, then fine, you could use it. Just be aware that it is not guaranteed to work. And now in OpenStack Icehouse, there was a new method introduced, volume retype, and it is virtually stable in Juno and Kivo, and it is right now. Volume retype is absolutely the recommended way to let Cinder do everything for you. You can change parameters within a single backend. You can use it just to change your volumes parameters without migrating it anywhere. Or you can migrate it to another instance of the same backend, or you can migrate it to a new backend. It is just a single command, and Cinder knows what to do. Of course, it is not always the fastest way, but it is virtually guaranteed to work. And well, the only, besides it not being the fastest way, the only downsides that I can see are that, yeah, you need to be running pretty much recent release of OpenStack because it only appeared relatively recently. And an internal consideration, you have to be running with the new version of the Cinder API, which is, I shouldn't be calling it new because it has been recommended for like maybe 2 years now, and the old version of the API is due to be absolutely phased out in the next release in OpenStack Liberty, but still there are third-party applications that have not yet migrated to the new API, and if you are unlucky enough to be using such an application, you have to bug the developers to actually get with the times. Because, well, that's what should be done. So, here we are at a meetup about the clouds, and it seems that the clouds have something to say about it. So, in summary, if you want the easy way and are not very concerned about the speed of execution, just use the recommended Cinder ways: Cinder retype, Cinder migrate. And if you want performance, check, just look if whether the backends can actually do it by themselves, or if not, check if it would be faster to do it with the operating system tools. And basically, that's it. That's what I had to say. So, yeah, a question? So, if you want to, so the question was which of these methods can be done online? In most cases, well, online, you mean which of these can be performed on a volume that is actually attached to a running instance or something like that? Yeah, okay. In that case, migrate and retype the Cinder, the actual Cinder options support that, and they have internal hooks to ask Nova to let Nova know that they are migrating the volume, so it can suspend the instance for a moment or something like that, or freeze it or something like that. And Nova actually does callbacks into Cinder, so the work is done in Cinder, but Nova is aware of it. So yeah, the Cinder retype and Cinder migrate things should work. Yeah, that question? So the question was, what would I suggest for backing up volumes? It depends on the backend, basically, but in some cases, snapshots, volume snapshots are good enough. But it really depends on the backend. I mean, I don't know. The way I imagine it and the way I have actually done it is use OpenStack, use Cinder to create snapshots like every day, and or every hour or whatever you need, and delete the ones that you are not using anymore. But it really does depend on the backend, because in some cases you may run into stuff like limits, how many snapshots can there be active on any given volume at a time, or how many snapshots there may be active at all in total in the storage backend. But if you can do it this way, this should be the best way. And of course, again, depending on the backend, removing old snapshots might be a costly operation, depending on how much the data has changed. But I don't know, I have found that it is usable. It usually works for me. Yeah, okay. My question? So the question is, can Cinder snapshots be used, be exported for disaster recovery? Again, it depends. I mean, some backends allow you, once you have created a snapshot and if you know how to access the underlying snapshot, some backends allow you to mount it as a file system or to see it as a device, and then you can do whatever you want with it. But actually, there has been talk about it again at the Vancouver Summit. I heard that, I just learned that there are some backends that do not actually allow you to access the snapshots as block devices or to export them. So again, it depends. But in most cases, it should be possible. And actually, OpenStack has a way, Cinder has a way to create backups, and you can configure it to create various types of backups, like store the data into Swift or back it up to an NFS server somewhere or something like that. So basically, it is whatever works for you. I mean, it depends on the backend, and it depends on your setup. I mean, if you're not using Swift at all, introducing Swift just for backups might not be the best idea. Okay. So, any other questions? Okay, thanks a lot.